Hello, everybody. Welcome to Starfleet Tactical. I'm Chris Weave. I am here by myself tonight. Well, I've got Buddy, my cat, as always. He was sound asleep until about 45 seconds ago. And then he, because he always does this, he sleeps right before the show so he can wake up and be on TV with me. So in any event, I'm solo tonight. Pat is actually relatively nearby. He's in Cincinnati, Ohio, visiting his in-laws with his family. But he's taking the night off in order to do that. And so I am flying by myself tonight. So a while back, I talked about the idea of doing, you may recall I gave you guys the option of picking which presentation I would do on a night a while back, the last time I was solo. You guys picked the one, I can't remember what it was. I think it was aircraft carriers in space or something like that. And so I ended up doing the other one. I said I would do it some future time, and that was this idea for what we're calling a rotary container ship. This is a product that View 9 and put together at one of our annual meetings a couple of years ago. So I actually thought about doing a new presentation on modular ship construction. I still want to do that, but I realized it was a way, way, way bigger topic than I had time to do in the time I allotted myself to do it. So it was one of those topics that just kept getting bigger and bigger and bigger the more I thought about it. So I think it's actually going to be a couple of presentations now when I finally get around to it. So instead of getting modular ship construction, you're going to get rotary container ships, which, as you'll note as you watch it, has a lot in common with the idea of modular ship construction. So also, just before I forget, two things. The first is I speak for myself, not any employer, past, present, or future. And the second thing is that I still need to go back and update the notes and put notes and comments from the last couple of shows. I just haven't gotten around to doing it. I've been up to my eyeballs in a couple of different projects, including hosting a wargaming conference the week after next. So if you look for connections online, you can find that conference. And if you want to attend, it's like $5 to attend. So, and we're doing it on YouTube using StreamYard. So you can thank Alec and Lissa for the mechanism whereby that conference is going to be done. As far as I know, Alec is still waiting on internet. So I haven't talked to him in a little while, but with that in mind, Stoggy, if you would go ahead and serve my slides. Okay, so let me switch over. All right, so this presentation is on something called rotary container ships. And Buddy, you're not helping. My cat is not helping. Okay, so this is basically the outline of what we're going to go through tonight. That's basically all the slides, so it's not as much as it looks like. I think there's 27 slides in this presentation, so we'll go through that. So, as I said, we're going to talk about something called a rotary container ship. And the idea behind this thing is that it uses a standardized shipping container and cargo handling systems, but they're based on gravitic technology as opposed to just schlepping stuff around with cranes. Within those constraints, there's a lot of variety there that you could use to implement such an idea based upon how individual shipyards want to do it, what the customers want to do, what various companies want to create. It's basically, it's a set of standards, and if you meet that set of standards, you can play in this field. It's really kind of like the way containers work these days, and I'll talk a little bit more about that. And all of these designs share the inherent property of construction modularity, and what I mean by that is that when you're building the thing, you've got modules, and you can assemble the modules into the thing. We'll talk more about modularity later. So a few caveats. This is not an Omniverse ship. It looks like one. It could be one. We proposed it to David, but he wasn't interested because he's got his own idea about how container ships work in the Omniverse. And we decided that the right answer was just to not make it a canon thing, to keep it as our own intellectual property without any honor-verse contamination in it. It does use honor-verse friendly technology assumptions. We're assuming gravitics. So assume all the same sort of technology that you see in the David Weber books. We could easily revalidate this with other tech assumptions. It doesn't have to have gravitics. It doesn't have to have those tech assumptions, but they solve some of the problems. They make it easier. So we went ahead and did it that way. This is very much a work in progress. All the artwork that looks good, which is all the artwork that was done by Brian Haven, was done over the course of 2 days. He did all the stuff, and then we threw that away, and he redid it with a higher fidelity. I've thrown together some things to illustrate things that weren't included in his illustrations, but it's by no means a finished product. There's still a few places where it's like, that illustration's wrong because we changed things afterwards. We need to add a little detail there, et cetera, et cetera. So, and we're also just still thinking through some of the details of this, but we're pretty sure that the fundamental concept works. It's just getting some of the details down that we're not quite sure about yet. So this slide is not yet finished. It's probably going to end up being a couple of slides where I'll talk about sort of the background history of containerization. The short answer is on this that containers were invented in the 1950s, specifically because the guy who invented them wanted to ship to particular locations. He decided that if you put stuff on the containers, his original conceptualization was that he'd just ship semi-trailers. You just pick the entire trailer up, put it on the ship, and then when you get it to its destination, you can lift it off and attach it to a semi and drive it away. He later decided, no, I don't need the wheels. They can provide their own wheels. I just need the trailer box. And so he had a certain number of these boxes made to order and started a shipping business in the Caribbean. I think they were going to Puerto Rico, if I remember correctly. And that sort of puttered along for a while. And then they got the contract to support the U.S. Army in Vietnam during World War II. And the end result of that's where it really sort of became popularized. The entire idea behind this is that it's an intermodal transport system, because the hard part about moving stuff from point A to point B via ship was that you never knew how long it was going to take to do stuff. And every time you shifted modes of transportation, a bunch of guys had to go in and carry boxes. And that was really inefficient. So that old image that you have of a crane lowering down into the hold of a ship and they bringing up a bunch of boxes in a big net, yeah, that largely doesn't exist anymore. And back in those days, to unload a reasonably small ship, it would take you a week or two to unload the ship using that methodology. With this new methodology, instead of having, and those guys have to load it onto a truck by hand, and then it goes to a warehouse and they unload it by hand, and then they later load it onto another truck, and then they take it to a train yard and they load it on the trains. But no, they don't do any of that stuff anymore. What they do now, a crane picks up the box, puts it on a truck, it gets stacked in a warehouse area, then later another crane puts it on another truck, and then it goes off to a railroad and they put it directly on the railroad car and it leaves. And so the only people that you have dealing with this are the people driving the trucks, the people driving the trains, and the people moving the cranes around. And so you basically got 3 guys instead of an entire group of guys, and every operation involved in it is very fast. And the shipping container can start in Shanghai and end up in Chicago. And then they will ship it back filled with goods going in the other direction. So it changed the world. This is why it's cheaper to move something from Hong Kong to Los Angeles than it is to move it from Los Angeles to Chicago, despite the fact it's so much longer to cross the ocean. It's because you can just load it onto a ship, and ships are really efficient. And as it moves along, you just have cranes moving it around. It's a fantastic book, and you should all read it. So that was way more time than I intended to talk about this book, but it's really important to understand how this works. This is how the global economy works. So, okay. All right, so almost all shipping in the modern world is done using specialized container ships. There are a few exceptions to that. Tankers, they do liquids. You've got bulk freighters that do grain. You've got break bulk that does oversized objects. You've got ro-ros that are roll on, roll off, like automobile carriers. They just drive the cars on. Technically, ro-ro is more about the access. It's not about the type of cargo on board, because you can ship containers on ro-ros. It's just that you have specialized things that pick up the containers and drive onto the ship. Ro-ros usually have a big ramp, either in the front or stern. Usually it's on the stern, that they can put this ramp down and you just access it with vehicles. My friend Peter Gold has worked on ro-ros, and he was the engineer on a ro-ro, and I got to take a tour of one, and it's fantastic. At some point I'll try to put together a presentation based upon that tour, because I took lots and lots of photos. You've also got heavy lift ships that are designed to lift things like oil rigs and other ships, etc. And they usually partially submerge to get underneath it. You know, they partially submerged. You float the thing over it, and then they blow their ballast tanks, and they come up, and then they carry it off. Container ships do require purpose-designed port facilities in order to do it, and that's another part of this, how the world has changed. New York City used to be a tremendously large port, and now it's not, because it couldn't handle container ships. And because it was such a large port, you had all these factories in Brooklyn and the Bronx that were specifically there to ship to the port of New York City and ship stuff out. And back in the 1950s, 1960s, early 60s, just as this was really taking off, they spent a godzillion dollars totally rebuilding the port of New York City, and then they never used it, because they instead ended up building a new container ship port at Elizabeth, New Jersey, and now all the traffic goes to Elizabeth, and that port in New York City doesn't even exist anymore. So containerization has really defined modern shipping. It's made or break ports. You know, they're important ports are no longer ports. Places that were just empty marshland are now the drivers of the global economy. It's really fascinating how all that stuff worked. So this group of us from BU9 decided that we wanted to take that idea and sort of apply it to the Honorverse, because we knew from talking with David that in the Honorverse, shipping is incredibly efficient. On a per mile basis, it's the cheapest form of transportation ever. And even though the ships are really big and really expensive, they can move stuff for dirt cheap across vast distances. And so that implied to us some sort of container-like functionality like this. So we decided we were going to design it. So let's talk about real-world containers for a second. I'm sure that you all had this image in your head when I said container. But basically what we're talking about, they're about 8 feet wide. They're a little over 8 feet tall, although you've got some new standards that are a little bit taller than that. They come in a couple of different lengths. 20 foot is sort of the original size, but now 40 foot is really kind of the standard. 20 and 40 are the standards. When that container ship was stuck in the Suez Canal, if you looked over the overhead views, you could see that some of them were 20-foot containers and some of them were 40-foot containers, because they can sit right next to each other in those stacks. You know, 2 20s equals a 40. And they're designed to do that, so that when you stack them up, you can put 2 20s where a 40 would go. But there's new sizes that are increasingly popular that make it harder to do the stacks, but basically 20 and 40 get you most of what you get. If you look in the corners, you can see where the twist tie connectors go in. So basically these things are designed that when you stack them up, you put a connector between them, and that locks them into place, and you can connect them to the ones next to them. So that big stack of containers behind it, if they've got their connectors going on, it's not going to move. They're just going to stay there. It's like having a building. So containers are they're fundamentally designed to work like Legos, and they do. Okay, I already talked about how containers are intermodal. They're used for the entire transportation chain from the factory to a warehouse loading dock in the real world. And we made that exact same assumption when we were going through and designing this ship. We decided that it was going to be from the factory onto the starship to the warehouse loading dock at the destination and everything in between. So the idea is that a truck might pick it up at a factory in one location, take it to a port, and then it gets delivered to some location in another star system. We made the assumption that future ground containers will be based on a similar standard to the current standard that we use today for the same sorts of reasons, that it's about the right size to fit into loading docks, et cetera, et cetera. With gravitics, you could conceivably have something that's a lot bigger, but we decided this is about the right size. It's something, you know, you might do bigger, but it's a nice size to work with. So we just sort of said, yeah, it's good enough. So we'll do something about that same size. We also decided, though, that you needed a separate container to be manipulated when you're in orbit and when you're moving stuff around in the ships, et cetera, that having a 6 million ton freighter carry these relatively small containers, these 40-foot containers, was just going to be too much. Instead, what we would do is aggregate them into a bigger container. So they basically slot into something that would hold a group of containers together. And then you use tractor beams and tugs and stuff to move it around. And as a result, those things can be pretty big. And I'll give you dimensions in just a second. We also made the assumption that any specialty containers would have built into the container whatever support services it needed, but they might have to plug in for data and power. You still have to control the things, you still have to provide power to it. But if it's a refrigeration container, it's got the refrigeration equipment built in. You just have to plug it into power. So that's the default assumptions that we were operating under for this. So here's what we came up with as sort of the big picture. There's two different types of shipping containers that we're talking about. There's two different standards of shipping containers. And those standards are basically, they're based on the size, how they connect to each other and plug in, et cetera, and how the connectors work. And so later on, when I talk about ship modularity in that other presentation, you'll understand that's actually a really big deal, that it's really about the interfaces. The stuff that happens inside the box can be whatever it needs to be to get the job done inside the box. It's the connection to the outside world that you really have to worry about. So in this case, we concluded there were two separate standards. One is the planetary shipping container, which is a little bit bigger than the current 40-foot units. They're 3 meters by 3 meters by 12 meters. So instead of that, which would make it about 38 feet by 10 by 10, approximately. So it's a little bit bigger. And I'll be honest, those numbers worked. I mean, it's just, I wanted round numbers. I didn't want this 8 foot 6 inches stuff. I wanted round numbers, so we picked round numbers. And these things are a little bit, they're about the size of a semi-truck trailer, but they're a little bit smaller than that. And then the things that they can plug into when they're going on a starship are interstellar shipping containers. And they're much bigger. So they're about the size of a small 3-story building. So think of a grid of 27 of these planetary shipping containers arranged in 3 rows of 9 each. And that grid, that interstellar shipping container can just be a framework so that they're all locked together and they can manipulate it. Or it can be a separate thing that actually doesn't carry planetary shipping containers. It's just that size and it plugs in to all the things that it needs to plug into. Or it can carry smaller things in it. Yeah, there's all sorts of different options for it. Once you've sort of defined the standards, you can, how the interfaces work, et cetera, you can do whatever you want within those standards. So as I said, the standards based on size, mounting and handling points, basic power and electrical connections, should also say data connections there also. And that, you know, they can be rated for things like heat, cold, pressure, et cetera, can have those separate sorts of ratings. So some containers might be inappropriate in certain situations, but others might be able to take care of basically a wide variety of things. Now, you can have ISCs that basically do the same thing as a PSC, an interstellar shipping container that sort of replicates a specialty of a PSC. So you've got a planetary shipping condition that does a thing, and that thing, like maybe it's a refrigeration thing. And you can have interstellar shipping containers that do the same thing. If you need to refrigerate something that's the size of a building, you can refrigerate something that's the size of a building. Actually, a better analogy might be maybe the PSC holds pressure tanks. So like you're shipping methane for whatever reason. It's got spherical pressure tanks in it. Well, you could have an ISC that's just bigger spherical pressure tanks. Or you can have ISCs that are designed to carry the PSCs. So it's kind of fractal in that as long as you fit within that, you can have small containers that do something, you can have big containers that do the same thing, or you can have big containers that carry the small containers. I'm kind of pounding on this a little bit because later on when I start talking about all the different things that you can do with these things, it can get a little confusing. But the important thing to keep in mind is the size of those different shipping containers, the fact that if you want to move a planetary shipping container through space, it has to plug into at least a framework for an interstellar shipping container. But you can also use interstellar shipping containers as a separate default size that you can do things with. Okay, so let's talk about planetary shipping containers a little bit. So as I said, they're the basic template. It's the stuff you move around on the ground, and as a result, if it starts off in a factory in one location, you can just take it to the spaceport. It gets plugged into the shipping unit. It gets taken up to a starship, loaded on a starship, driven to another system, and they do the same thing in reverse. It looks a lot like a standard shipping container. It's a box with doors on one or both ends. It may be vacuum tight. It may not be vacuum tight, depending upon the standards, etc. You can have specialty ones like refrigeration tanks. You can have habitation rated ones. Yeah, so basically like a mobile home sort of thing. That's the sort of thing that the U.S. Army does all the time. I know a lot of guys who lived basically in shipping containers. But they're special shipping containers. They're designed to be sort of little one-bedroom apartments when they went overseas. You can have a life support module that's basically designed to plug into an interstellar shipping container that's really sort of functioning as a barracks or a habitation module. So you want to send this thing to another planet. It's going to end up on the planet as sort of plopped down as a building on the planet. So you've got this life support gear that it's not going to need once it gets to the planet. We'll talk more about this when we get to the colony ship variant at the end. So you can then take out that piece of gear and take it back with you. So there's all sorts of things that you can do with just slotting things in and coming up with planetary shipping container form factor type objects that you can do all sorts of things with. They all have whatever computing capability built into it to do whatever environmental monitoring and to maintain a manifest of the content. So everything is got chips in it. You can tell what's supposed to be in it. It's got all the computers that it needs to. We started with the default Omniverse assumptions, and this is a universe where baby carriages have supercomputers in them because they can. Supercomputers are something that you buy out of vending machines. At least what we would consider to be a supercomputer. So if you putting all that stuff in is really pretty trivial. So we assume it's all there. So this is kind of a schematic of what it looks like. Because we picked 3x3 by 12, it specifically boils down to the sides and the top kind of look the same, unlike an actual shipping container where they're a little bit taller than they are wide in the sort of the baseline version. And then it's got doors on one or both ends. So it may not have doors on both ends. It could have doors on both ends. Or maybe we're going to make a decision about which it should be. We just haven't made that yet. So let's talk about interstellar shipping containers for just a moment. They, like the planetary ones, they've got whatever stuff built in that they need to sort of do their thing. Passenger ones might include the life support module, although, like I said, it might be removable if the end goal of that passenger module is to end up down on a planet. Doesn't necessarily have to be built into it, but it's at least got a place where you could slot it in. They plug into the freighter's power and communications networks as needed. Basically, they're limited only by the form factors. So you got the one that carries planetary shipping containers. You've got various human-rated designs so that you could turn your container ship into with a few restrictions here and there. You can turn it into a passenger ship. It could be a hospital ship. It could be barracks. It can be all sorts of different things. You can use it as a colony transport using special shipping containers designed to be left behind on a planetary surface. There's usually some sort of life support module sort of built in if it needs it, or there's at least a slot for it. You can use it as just basically a framework to transport large objects. So if you got something that's really, really big, like maybe a boat, you can put the boat in that thing, and then you've got the place to grip it, and you can manipulate it and slot it into place. And then when you get there, you just sort of take the frame off, and you've got your boat. You can have tankage. You can have all sorts of objects that are really just sort of designed to that same sort of form factor. And here's what they look like. So what I would note here is that the doors are segmented so that you can open and close the doors separately. Those doors are important because they might need to be inspected during flight, and I'll talk a little bit more about that when we get down to the actual ship. If you look at the side view here, which I guess I don't need those lines there. I could take those lines out because the lines aren't on the sides. I put the lines in to sort of illustrate that it's 3 levels there, but if you look, you'll see that there's these green lines in the front, on the lower right-hand corner illustration. There's those green lines. That represents a door that's been folded down. And the idea is that when these things are like on the ground, you can fold that door down, and there's sort of spring-loaded railings and stuff like that that pop up, and maybe even a stairwell, so that you can access all this stuff. And it looks like a motel when you do this. You can get into the individual containers. You can slot them in using gravitics, etc. Or you can close that stuff up, and it's got enough of a gap underneath that those doors can be slid underneath and out of the way if you want them out of the way, or they can stay out so that you can use them as a balcony to access all that stuff. So now we're going to talk about the container ship itself. So our postulation when we went into this is that there's 2 basic types of container ships. There's non-rotary ships that are really sort of analogous to current container ships, and then there's rotary ships. The current container ships have, you've got large hatches that you might, for the Omniverse at least, you'd have large hatches that the things go through. The containers are loaded in a last in, first out sort of methodology. There's no ability to really move containers around while they're in transit. There's very limited ability to access containers in transit. And those last 2, all of this is really kind of what we're trying to fix with the rotary ship. That's the last thing I'm going to talk about, the non-rotary ships. From now on, I'm talking about the rotary container ships. Okay. So here's a section of this rotary container ship put together by Brian Haven. So thank you, Brian, for the artwork. It's built as a series of cylindrical hull sections, and there's 3 types. There are the sections that contain containers, that are designed to contain containers. There's the sections that are designed to allow you to access the core hull. And so basically it's where you would have a big access to the outside, like where there's a boat bay or things like that. Well, and then there's also, at least in theory, open hull sections that are for specialized items. But in most cases, our assumption is that for most freighters, you just put them in those core access hull sections. You just put them in at the end after you've loaded other stuff around and you've used that section there. But the idea is that you can bring containers in through a couple of different places. You can bring them in through doors on the sides, which aren't illustrated here, or you can bring them in through that door on the bottom, which is also where the ship's boats and any tugs that it might carry, because it might be that you're going to a system where you got to move your own containers around, right? If it's an undeveloped system. For us, you're going to a major port, maybe you just show up and you just spit them out. Talk a little bit more about that later, but it might be other places that you have to actually move them around yourself. So each of those container hull sections is a series of concentric rings. The number of rings that you have inside to out is based upon the diameter of the ship. The number of sections is based on the length of the ship. So you might have a ship that only has 2 rings around and only has 5 sections. That would be a very small ship, or you can have this thing, which is pretty much a behemoth. So that's the beginning of how that works. So let's go to the next one. All of these rings, or most of the rings actually, except for the centerline ones, are capable of rotating around the centerline. So the inspiration that I got that caused me to start thinking about this was the cylinder of a gun, of a revolver, and the idea that, like, what if you had 2 rows of locations for bullets and you could rotate them around, and what if they could rotate independently? And so the idea is that these are able to rotate independently. Basically, they're a set of rails, and they can sort of rotate on top of each other, so that you can line up gaps and you can move the containers through those gaps. And so you use gravitics to sort of pull them from one, and pull and push them from one location to another. If you look at the very front of this illustration, you'll see that there's a gap built in there, and the idea is that those are just, we took out the framework that all the containers are actually sitting in to illustrate this point. But what's basically going on there is that there's an empty slot across the board, and they can slide through that empty slot to either get into the center core tube or to get to a door to the outside if there's one on that particular section. So I should probably say there's container sections with doors, and there's container sections that don't have doors to the outside world when you're loading and unloading containers. So basically, you're going through those doors to the outside to load and unload. You're going through the core primarily when you're needing to move containers around while the ship is in transit, and I'll talk about that when I get down to operating concepts. So this is what one of those container sections looks like a little bit more up close. The one on the left has that extra framework, and it's got those sort of wedge-shaped floors designed to keep everything nice and oriented. Those floors have whatever machinery is needed to support those containers, and they sort of plug in. That's the one that's closest to the core. So I think what we're seeing there is the core, not the inside of the ring. The rings basically are just a wire framework, and they're attached to the bulkheads that are at the end of these sections. So there's basically a wall on either side of the section, but the rings themselves are basically empty except for those wedge-shaped structures that are contained as part of the ring. And you'll also note that if you look in that first one, you'll see that there's one ISC there, but those rings are actually 2 deep. So every time you see one of these sections, there's actually 2 sets of ISCs there, two layers of ISCs, not one. So, okay. As I said, the number of rings is determined by the diameter of the ship. Containers are attached to the outside surface of each of the rings, or they're attached to hard points. We've actually been changing sort of our thinking on this. Originally, there was structure there, but we're cutting back on the number of structure. The outboard rings rotate. The ones attached to the core probably don't, but everything else rotates. Because it is attached to the core, and everything's sort of attached to it, and attached to, there's rails on the walls, the bulkheads, that they're all attached to also. Our thinking is that those inner ones are designed in such a way that that's where you'd put the passenger modules. It's got all the extra stuff that you would need to have passenger modules, and the passenger modules all have airlocks or passageways or connectors that so that humans can get through it, doorways that line up with that with some sort of structure on there that allows you to move around inside the ship. So it's not a case that you get loaded like cargo and then you're just stuck in this ISC for the duration of the voyage. You can get out of it. You can move around the ship. And so that leads to the possibility of there being like an ISC that has a gym, and there's another ISC that's basically the food area, the dining room and stuff like that you could have on these inside structures of this ship. And as I said, these rings all rotate, and one of the reasons why they'd rotate is so that you can line up whatever empty spaces so that you can move those ISCs around inside the ship. Okay, so there's I talked about a little bit about the core access stations. There's one either at either end of the cargo section or maybe one in the middle, depending upon how you design the ship. And that's that sort of area in the middle where you don't see any rings. And if you look carefully at the bottom, it'll show up. It showed up better. You'll see it again when I pull the big version of that up. There's a door at the very bottom. And our thinking on that is that in an honor-verse ship, you'd have sort of the people part, the crew part at the very top of that cylinder. And you'd have like a boat bay up there where you can store equipment, you can store boats, etc. And that gives you a fairly large area that you can store ships, boats, and you can also store big articles that wouldn't fit inside one of these containers, like maybe a fusion reactor or parts of a space station or something like that. They can fit in those spaces. You can put some of that stuff in the core if you need to, because the core is pretty big. But you can also store it in these other areas that would normally function as hangar space. Let's see, I think that's about it for that. So let's talk a little bit about the core. Now, this illustration is wrong. That tube shouldn't be there. The idea is that the core is just a hollow cylinder, but it's big enough to allow, say, 2 to 4 ISCs to pass by each other. And it lets you transfer ISCs between rings, and I'll explain why that's important in a moment. And it also lets you put in extra large cargo. And so we purposefully, have sized this thing so that you can at least have 2 going by each other. It also allows you to do things like if you need to do an inspection, like say a customs inspection, you can pull an individual ISC out, pull it through the core to a special station that's probably like at the top of that access, so that you can actually access the content. So it's not like a modern shipping, a container ship, where you've got this thing in there and it's in the middle of the stack and you just can't get to it. In this, the idea is that you can get to any ISC. You can pull it off, you can take it to a special station designed to allow you to inspect it, and you can mate it with that and you can inspect it. Oh, and one thing I should have pointed out early on, since we're assuming that we've got gravity manipulation technology, if you've got these things oriented, the assumption is that at least in the bay, gravity is coming out from the core. So down is towards the core. So if you've got different passenger modules around, their feet are all pointed towards the core. So how big is this thing actually? Well, the answer is pretty damn big. This particular section here, my calculation is that it can hold almost 1,800 ISCs, which is the equivalent of almost 4,800 planetary shipping containers. Which is, if you look down at the Maersk Triple E class there, ultra-large container vessel, it's one of the largest vessels in the world right now. It can hold about the equivalent of a little over 9,000 of these things. So let's see, that's 6 times, yeah, that's a lot of containers. It's a lot of container equivalents. Much, 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 much larger than anything we have on the sea today in terms of its carrying capacity. So the concept of operations for this, we wanted the goal of minimizing time in port, because that's actually really important for modern container ships. Remember how I said it used to take a week or two to unload a ship and then load it up again? These days, a container ship will come in, and they're way bigger than the old freighters. That container ship will come into port, and it'll be in port for 6 to 8 hours. And they're just constantly pulling containers off, and they put new ones on, and then it's ready to rock and roll. So we assumed that we wanted to minimize time in port, which means maximizing the speed of the on and the offload. And we also decided we wanted to concurrently be able to on and offload containers. We also decided that specifically that customs inspection thing I talked about was actually important. We wanted to maintain ease of access to specific containers. We wanted to be able to pull those things out. And that'll become a little bit more important when I talk about military variants later on. I'll expand upon that a little bit. So when a ship arrives in system, let's assume it comes in fully loaded. You've got cargo doors on the side of the craft, and it starts spitting them out, right? The ones that are going to that system. Now, sometimes you've got container ships that are designed, they're just going back and forth between two locations. So they may be going between, say, Shanghai and Amsterdam, and they just go back and forth and back and forth and back and forth. And so you never have to worry about where the destination is. You know exactly where it's going. Doesn't have to work that way. You can do a triangular trade or even more. We wanted to have the option of they're doing a set route. So they're doing an outbound leg and an inbound leg, stopping at multiple places along the way. And so if you're doing something like that, you want to be able to make sure that when you get to a port, you're spitting out all the containers that that port needs, and that those containers are ready to rock and roll. So you've got all the containers for a particular port ready to immediately spit out. And I haven't decided yet whether the way this works is that you're going out one door and in is coming in the other side, because the assumption is you got doors on either side of the ship, or whether it's out and then in, out and then in on both sides. And so you empty a slot, you shoot one out to empty the slot, you then refill the slot, rotate, do the next one. Could be either way. Don't know what's more efficient. But when they're coming in, they don't pay any attention to where it's going when it's coming in. They just load it into the first available slot, because the important thing is doing it as fast as possible and not slowing down the offload. So that means that when you're in transit, you've now got a bunch of ISCs that are not optimized for the next destination. So that's where all this rotation and moving stuff through the core, etc., comes in. You come into, as you're transiting to the next port, you defrag your freighter. You're moving containers around. You shift this one here, you send it to the back, you pull the others to the front. You line it up so that when you get to the port, the containers for that port are right by the door, and you can spit them out as fast as possible. You still have to do break bulk items in the core and stuff like that. Okay, that's a big issue. But in terms of getting the containers out, they're all optimized for the offload. And all these things, you got a complete manifest of everything that's in the ISCs. It's all computer controlled, supercomputers and baby carriages, right? So you certainly got supercomputers in the ISCs, et cetera, whatever you need to do to make that work. And so it's all computer controlled. And so at this point, you should be able to say, I need to see this container. I need to look in this PSC. The PSC that came from this guy and is going to this guy, and it's one of those 47,892, whatever it is, containers, and the computer will automatically be able to start, as soon as you can finish the query, it will start moving that ISC to the inspection location. Same thing when you get to the offload. It knows immediately what's there. Everything is chipped, RIFID type chips. It's all talking to the network and can tell you exactly what the status of all the stuff is, what the temperature and humidity, et cetera, is, and it just starts spitting that stuff out. Insurers would love that capability, to be able to say, no, actually, we can prove that it was under perfectly controlled conditions the entire time that it was on our ship. You need to blame the warehouse guys for the reason why all that stuff was broken when you got it, because it didn't break on the ship. So I mentioned colony transports at one point, and we spent about 2 hours, if I remember correctly, talking about the idea of turning this into a colony transport. And our idea was that colony transports usually are a little bit specialized. They basically look like one of these freighters, but they have a few extra capabilities in it in order to meet the life support requirements, because our assumption is that they're going to have tons and tons and tons of people, more than could just be in ISCs that are right up against the core. So you might need extra life support modules if you're going to try to use a regular container ship as a colony transport, and you may end up with some people that are sort of locked in their 3-story building ISC for the duration, which is why you'd rather have a specialized ship to do this. But in an emergency, like say you're doing a mass evacuation of a planet or something like that, you can use just regular ships as long as you've got the appropriate number of life support modules along to increase the life support capacity of the ship. We concluded that, and to be honest, I don't remember what the math was on this because I didn't write it down, and we need to go back and calculate it out again. But we concluded that a 5 million ton ship could transport 15,000 colonists, and we assumed all of their colony gear because we only used a percentage of the ISCs available on the ship for the colonists. And a bit, like I said, I don't remember all the assumptions that went into that. I just remember what the final numbers were. And the idea behind this colony transport is that basically all of the ISCs are going to stay behind on the planet. So some of them are specifically designed to function as buildings when they get down on the planet. Some of them are designed to function as garages. Some of them, the idea is that they've got PSCs in them, but the ISC itself is designed so that you can take the PSCs out and use them separately, and the ISC that's left is an appropriate building that can then be outfitted as a building of some sort. Basically it's all admin loaded, dense pack, lots of unfold this, et cetera, to make it all work. So you're able to put in more gear inside of it than what you would normally see in it when it's on the ground being used as a building. So in this case, it's not loaded for accessibility. It's loaded for maximum density. So you're not going to defrag it like you would normally. And as a result of that, the assumption is that you're going to use up most of that core and all the boat-based space, et cetera, with fusion reactors, space station modules, all the other things you need to put in for a colony. And there's probably going to be some extra ship-to-ground cargo shuttles that you're going to leave behind. So this thing is going to be packed to the gills, and a lot of the spaces that on a normal transport, a normal container ship, you'd leave open so that you've got enough space to move things around. In this case, you're dense packing it. So you pack your storage unit differently than you pack your apartment, right? So it's going to be packed like a storage unit, not packed like an apartment. So what other possible civilian variants are there? Well, okay, maybe there's special passenger ISCs that are available that they're designed so that they sort of connect to each other more. And you can maybe even have holes in the bulkheads, or they probably actually go in towards the core, but maybe you've got stacks of them and you've got ladder wells where you can go down towards the core, or maybe even elevator shafts if you line them up so that you can get down and then get out in the core and go over to the next section and go into the next section. In that case, you're probably not rotating that stuff around. You're probably going to lock it in place. So there's probably some safety overlocks designed to make it work that way. But if you've got the right ISCs and the right programming, you can probably do it. You could use something like that for disaster response, humanitarian assistance, those sorts of things, or maybe just as troop transports. Anything that can fit in that ISC form factor can be put in the ship. And that includes, you could put probes in there. You could put survey vessels or fighters or something like that. You could basically treat those ISCs like they're portable hangars. So maybe it's an open framework, or maybe it's a framework it's got walls on all sides but one. And when you go to launch the ship, what you do is you move its hangar to the door, and it launches, and then it puts its hangar back where it stores the hangar. Okay, maybe that works. Maybe the survey vessels, whatever, come in through the core and end up in hangars that are around the inner side with their openings pointed in. There's all sorts of things that you can do with that form factor. It's a really pretty good size form factor, and anything that you can conceive fitting in this section that's 13 by 13 by, I think it was 36 if I remember correctly, if it fits in that volume, you can put it in a framework and manipulate it within the ship. And if you've got ships that are owned by the Navy or subsidized, they may have additional requirements. That's one of the things that you frequently see in the real world, and you certainly see it in the Honorverse, where the Navy will subsidize certain ships, but they have to have special requirements. And if the balloon goes up, they can get drafted, and they end up going and doing stuff for the Navy. But the end result is you end up with a subsidized ship, so it's a lot cheaper to get the ship that you want. You just know that that's what ends up happening. Airlines do the same thing. There's provisions that airlines get money from the government, but they know that in the case of a national emergency, the government puts down their marker and says, yep, we're taking those airliners. You're going to provide services for us instead in exchange for all that money we gave you previously. So let's talk about military implications. So like I said, anything that can be designed to fit in that form factor can fit in that form factor. And that could be weapons pods, it can be fighters, torpedo boats. Like I said, you could have the framework as an individual hangar, sensor pods, communication pods, deployable arrays, all sorts of different things. And if you think about it, that's kind of what an aircraft carrier is, right? Aircraft carriers redesign themselves by getting a new air wing. You want to upgrade the weapon system on an aircraft carrier, you fly the old airplanes off, you fly new airplanes on. And a lot of the sensors of an aircraft carrier are in the form of airplanes that carry radars and sonars and stuff like that. So it's and they used to carry sonobuoys. They don't anymore, actually. That's all provided by their assets, but they could. In fact, that's a good thing. That's an illustration of my point. At some point, they decided that wasn't as important, so they took those airplanes off. They changed their mind. They can put those airplanes or replacement airplanes back on, and they can change the capabilities of that warship. It is worth noting that in most cases, a military ship is not just a civilian ship with a gun, but there's a reason why I included this particular stamp in the lower right-hand corner. That is a British East Indiaman, which were basically warships with guns. They were freighters designed to also be warships. And indeed, in the early part of the Age of Fighting Sail, there really wasn't a difference between freighters and warships. They were really just freighters, and some of them had guns on board. And, you just put guns on board if you needed to fight. By the time of, say, like the 1700s, that had largely fallen by the wayside, with the exception of the British East Indiamen, which were designed to have some credible combat capability. They certainly weren't going to take on a real 80-gun ship. But they were designed to be pretty credible for the environment that they had to operate in. And that works if you plan ahead. So what does planning ahead look like? Well, let's take a look at what planning ahead looks like. What do you need to put on it in order to turn it into a military ship? Well, you need to have offensive systems, and those could be containerized in ISCs, right? Just like you could put missile pods, you could put all sorts of things in those pods, and you could deploy them. You can partially do the same with defensive systems. You're not going to fly your armor around in a pod. That doesn't help you at all. But you can have potentially if you've got something that looks like a force field generator, you can put decoys, you can have point defenses that could be in ISC sized pods and deployed. Your sensors could also be containerized. Now, if you've got a big ship like that, you could put a big ass sensor on the side of it, but you might want to have probes that get deployed and sensors that go out. A carrier battle group has some really, really powerful radars in it, but they still deploy an E2C Hawkeye to go and see over the horizon. So there's no horizon in space, but you still might want to have deployable sensors that could be containerized like that. Propulsion is going to have to be built in, and if you need mil-spec propulsion, you're going to have to provide mil-spec propulsion. Your power might be able to be containerized. If you need extra power, maybe you can build a fusion reactor inside one of those things. There are implications to that, but maybe that's a possibility. Structure, whatever structure you need, you're going to have to build that in. You can't add that with the container. So you can't just get a full-up military system by saying, I'm going to bolt a gun to this ship. They learned that doesn't work when they tried putting guns on ocean liners. Ocean liners, they could put guns on ships that had specifically been designed to take a gun. But if you just try mounting a gun, you end up ripping up your deck. You end up damaging your structure and warping your plating and all these other things because it's just not designed for that sort of thing. So you'd have to really kind of think about it in advance. And like I said, aircraft carriers are really sort of the analogy here, which is why I included this model of a spacecraft carrier, because that's really the sort of thing that we're kind of thinking about. So it might very well be that what I've designed here is basically the space-going aircraft carrier of the science fiction future here. So that's pretty much it. That BU9 annual meeting in 2018, the people who were there were Arias Kaufman, Brian Haven, who did all the good artwork. I did all the crappy artwork. Peter Gold was there. Pat Doyle was there periodically, but he really only stopped by for about 2 hours towards the about 3/4 of the way through the process. And we said, hey, Pat, we had this really good idea and we've been working on it for a day and a half. Here's what we did. What do you think? And he gave us a little bit of suggestions there. Peter Gold was really just incredibly valuable in this as a merchant mariner, because the rest of us, to the degree that Brian's a former submariner, Pat's a naval reservist, Arias worked for the Center for Naval Analysis with me there. I've been at CNA and the Naval War College, etc. Not a whole lot of maritime merchant civilian type experience in this group. I've spent more time paying attention to it as of late, but this is really a group that was way more focused on Navy rather than merchant, and having an honest to goodness merchant mariner there to answer questions and say, hey, you guys haven't thought about X, was very, very useful. So that's the group that put this all together. With that in mind, that is pretty much what I've got for this evening. And it looks like we're finishing almost exactly on time. I actually kind of expected this one to run a little long. I'm kind of glad it didn't, because my throat's beginning to go. Let me take a little quick look and see if there's anything that immediately strikes me as a question that I should answer. Scott said something there that made me remember that I talked about offensive systems and defensive systems and sensors. I didn't specifically, I was sort of including it in sensors, and I shouldn't. I didn't specifically include fire control and things like that. So there's a lot of systems on a Navy ship that are designed to sort of tie all the sensors together and do the display for the people that are making decisions, and there's specific command spaces that do all that stuff, and all of those things are potentially really important. I'll note that a lot of that stuff could be containerized. I should add that to the list and put that as the thing that could be containerized. You could put a combat information system in a container and only load it aboard the ship if you needed it. So that's the sort of thing that you could do. Let's see. I think with that being the case, I think it's time to call it an evening. So thank you very much, everybody. Thank you, Stoggy, for producing.
You're most welcome.
And I will see you guys next week, most likely. Thank you very much.